Okay, here's my motor generator setup. We got the treadmill motor connected to our washing machine motor, which is at our generator. None of this here is connected. We have two of our phases. It's three-phase: blue, red, and yellow. We have two of the phases connected to our microwave transformer. We're getting out, a few amps at 1200 volts or whatever that is, going to our bus bar and to our capacitor. And it's set up sort of like the Aaron Murakami gray motor circuit, only on the output, instead of having the coil and it driving the motor, what I have here is a spark gap that goes to a 50 mega ohm resistor to one side of a light bulb, and then a 71 ohm resistor on the other side. One thing that I notice is that once I get it going, it charges up, and we have our meter here, actually discharge that. Okay, so reset. So what we're getting is a phenomenon where the voltage is actually going up after it turns off. So I wanted to show that. So let's turn this guy on, and we're on DCs because it's a DC capacitor. And you can see it's already going up. Nothing's even attached. It's not on. See, the light's not on. There's no watt going on. And it's already raising up on the voltage. Very interesting, right? And it's pretty quick too. It's not like it's a little bit. So let's turn it on, and I'll show you. Okay, so we're going to turn it on here. Take our safety off. Turn it up. And we're going to go up to about a couple hundred watt there. And we're reading about, and it's going up. But we're overloaded on the DC, so we're going to turn that off. Let's turn it off. I might have turned it up too high. But you see the lights going, and we got a spark gap is going. So I'm gonna have to actually discharge it because we did it too much. So let's start it over again. You can only run it for a second there. So I'll turn it on for a second. A little bit more. Okay, we'll stop it there. We'll take off our energy. Oh, see, now it's going back up to, so automatically, so the light's on, the thing is charging. Okay, we're putting too much energy into this for my meter. Okay, so let's start the meter over again. And there it goes. It's going back up again. Now let's turn it on. Okay, and we turned it back off, and it's going across, and the light bulb is barely lit. But let's look at this thing. Look at this. It starts increasing. No additional input. It just is going now. 190, 195. And it's still going up. Now, no additional input is happening. Okay? Nothing else. It's going a steady spark, and if we had the lights off, we'd be able to see the bulb going. It's obviously, not the right voltage for that bulb, but you can see it's still increasing and increasing until now it's overloaded. So, I thought that was pretty interesting, and you can see the bulbs getting brighter as it goes on. So let's see. Oh, we took off the. Oh, we have to have the meter on there. It takes off the load. It actually makes the light brighter. So let's see what we're at here. Oh look, it's even showing AC volts. That's going down now. Okay, let's go back up to our DC. Alright, so our power's going back down. So that was odd. Yeah, it was like once it was all connected and it was flowing, it started going exponential. Now that I took off the lead, which stopped the flow from happening inside the spark gap, now it's just going up and down. Now it's going back up again. And okay. So I thought that's an interesting phenomenon that nothing is being put into the unit, yet it's still going up and up and up in voltage. So I'm gonna have to see if that's just the resonance happening between the coil and the capacitor, if it's moving back and forth, which I don't think so because of the diode, or if it's just the capacitor just is so high of energy that just is dumping this energy over and over and over. And there it goes. It's going to go back up to overload, and we're going to have to take it off again. When we do that, the spark turns off. It's not enough to ionize and jump across here. Even though I think it might still be on, I can't tell with the light on. Let's see. Okay, we'll put it back on, and we'll put it back there, and we'll see the spark is back, and there it goes. It's it wants to go back down and then back up like it was before. And maybe it'll just go down now. Now it's continuing to go down. So now it's going back down. So I thought that was interesting. Even when you discharge it, okay. And then it goes back up. It starts raising again. Of course, it's glitching out. Start off and then turn it back on. So there it is. It's going back up again. Just millivolts, but there's no input. I discharged the capacitor. There's absolutely nothing happening as far as input. So what's going on there is the whole thing. Oh, there it goes back down. Anyways, might be the meter. But there's the setup. So this all can be replaced. It's just this can all be replaced by a solid state, which I have. Just connecting this to a pure sine wave filter, the transformer. So you can cut all this out. It's mostly just this LRC circuit where the resistor is actually a diode, so it's a switch. But yeah, I thought that was interesting to note. Well, yeah, there it is.